Most security testing attention goes to web interfaces. Login forms, search fields, profile pages. The parts of the application users interact with directly. But in modern software architecture, that is not where the real attack surface is. APIs are. Almost every modern application is powered by APIs. The mobile app calls APIs. The single-page web app calls APIs. Third-party integrations call APIs. Internal microservices call each other through APIs. The web interface you see is just a thin layer on top of dozens of API endpoints doing the actual work. And APIs have their own specific set of security vulnerabilities. Different from traditional web application vulnerabilities in important ways. Mostly because APIs were often designed with the assumption that only authorized clients would call them. That assumption turns out to be wrong. OWASP recognized this and published the OWASP API Security Top 10 specifically to address the most common API vulnerabilities. It is separate from the general OWASP Top 10 because the threat model is different. In this episode, we are going to cover the most critical API security risks, how to test for them using Postman and Burp Suite, how to verify rate limiting and input validation at the API level, and how API authentication mechanisms like OAuth and API keys create their own vulnerabilities. If your application has an API, and it almost certainly does, these tests belong in your test plan. The OWASP API Security Top 10 covers the vulnerabilities most commonly found in APIs. Let me walk through the most critical ones. Broken Object Level Authorization, or BOLA. This is the API equivalent of IDOR. An API endpoint that accepts an object ID without verifying the caller has permission to access that specific object. If your API has a GET endpoint at /API/orders/1234, does it verify that the authenticated user owns order 1234? If not, any authenticated user can access any order. Broken authentication. API authentication is often implemented with tokens, API keys, JWT tokens, OAuth tokens. Testing whether these are properly validated, whether they expire, whether they can be brute forced, and whether they are transmitted securely. Excessive data exposure. APIs often return more data than the client actually needs. The mobile app displays a user's name and email, but the API response includes the user's password hash, internal ID, admin status flag, and account creation timestamp. An attacker can read all of that even though the app only shows 2 fields. Lack of rate limiting. Without rate limiting, an attacker can make unlimited requests to your API. They can brute force authentication, enumerate objects by incrementing IDs, scrape all your data, or deny service to other users by consuming all server resources. Security misconfiguration. APIs that expose debug endpoints in production that have CRS configured to allow any origin, that include stack traces and error responses, or that use HTTP instead of HTTPS. Each of these is testable. Let me show you how. Postman is the most widely used API testing tool, and it has capabilities that make security testing significantly easier. Start by building a Postman collection that covers all your API endpoints. If your application has an Open API or Swagger specification, import it directly into Postman. This gives you a complete map of every endpoint, every parameter, and every expected response. For BOLA testing, create 2 user accounts in your test environment. Authenticate both accounts and store their tokens as Postman environment variables. Then for every endpoint that accepts an object ID, write a test that calls it with account A's token but account B's object ID. The expected result is a 403 forbidden or 404 not found response. If you get a 200 with the data, that is a BOLA vulnerability. For excessive data exposure, examine every API response carefully. Write Postman tests that assert specific fields are not present in the response. If a user endpoint should return name and email but you discover it also returns the user's hashed password, write an assertion that the password field does not exist in the response and mark it as a failing test until the team fixes it. For rate limiting, write a Postman runner that sends the same request 100 times in rapid succession. Check whether the API starts returning 429 too many requests responses. If it never does, rate limiting is missing or not working correctly. You can also route Postman traffic through Burp Suite by setting Postman's proxy settings to localhost 8080. This gives you full visibility into the raw HTTP traffic and lets you use Burp's tools alongside Postman. Let us go deeper on API authentication security testing. OAuth is the most widely used authorization framework for APIs. It allows applications to access resources on behalf of users without storing their credentials. But OAuth implementations have a long history of vulnerabilities. The most common OAuth vulnerabilities to test for: state parameter validation, redirect URI validation, and authorization code reuse. The state parameter is a random value included in the OAuth flow to prevent cross-site request forgery. Test whether your application validates it. Remove the state parameter from the callback URL, or change it to a different value, and see if the application accepts the authorization anyway. Redirect URI validation prevents an attacker from intercepting the authorization code by registering a similar-looking redirect URI. Test whether your application accepts partial matches, subdomain wildcards, or open redirects in the redirect URI. For API keys, test whether they are properly scoped. An API key that grants read-only access should not be able to write data. Test every key you have against operations outside its intended scope. For JWT-based APIs, apply the same attacks covered in the previous episode: the none algorithm, weak secret keys, and token expiration. A specific API pattern worth testing: does the API expose different functionality based on a user type field in the JWT payload? If so, modify that field and see if the server enforces the check server side or trusts the tokens claim entirely. Also test what happens when you send malformed tokens. No token at all. An expired token. A token signed with a different key. A token with a corrupted signature. A secure API should return 401 for all of these consistently. Input validation at the API level deserves dedicated attention because APIs are often less strict than web interfaces. Web forms have client-side validation, required fields, input length limits, format checking. All of that can be bypassed by calling the API directly. The API must validate input server-side independently. Test every API parameter with empty values, null values, extremely long strings, strings with special characters including single quotes, angle brackets, and script tags, negative numbers where positive are expected, decimal numbers where integers are expected, strings where numbers are expected, and arrays or objects where scalar values are expected. For file upload endpoints, test with extremely large files, files with unexpected MIME types, files with double extensions like image.jpg.php, and files with embedded content like an image file that contains executable code. For any endpoint that accepts a URL as a parameter, test for server-side request forgery. Try setting the URL to internal addresses like 127.0.0.1 or 169.254.169.254, which is the AWS instance metadata endpoint. If the server makes a request to that URL and returns any data, you have found a critical SSRF vulnerability. For mass assignment vulnerabilities, add extra fields to your post and put request bodies. If you are updating a user profile and the request normally only contains name and bio, try adding in his admin field set to true. Does the server ignore it or does it update the database? If users can set their own privilege level, that is critical severity. API input validation bugs are often missed because testing focuses on the happy path. Security testing is about the unhappy paths that the developer did not think about. Here is what we covered. APIs are the primary attack surface in modern applications. The OWASP API Security Top 10 provides a framework specifically for API vulnerabilities. BOLA, Broken Object Level Authorization, is the most common API vulnerability. Test it by using one user's token to access another user's objects. Excessive data exposure occurs when APIs return more data than clients need. Examine responses carefully and assert that sensitive fields are not present. Rate limiting must be tested explicitly. Send high volumes of requests and verify that the API returns 429 responses and enforces limits. OAuth implementations have specific vulnerability patterns: state parameter validation, redirect URI validation, and authorization code reuse. API input validation must be tested server-side, bypassing any client-side controls. Test every parameter type with unexpected values, and test file uploads and URL parameters for injection and SSRF. Next episode, the pen testing mindset. The difference between a QA approach and a security researcher approach, how to think like an attacker, threat modeling basics, and how exploratory security testing finds bugs that checklists miss. This one is more conceptual, but it is the episode that ties everything together. Knowing the techniques is one thing. Knowing how to approach a target systematically and creatively is another. Subscribe to QA Career Lab. See you in the next one.